Hello everyone, my name is SN Patil. In this video lecture, we will discuss problem on a sphere. Here, the question is find the equation of sphere which has its center at 2, 3, -1 and touches the line. This is symmetrical line. X plus 1 divided by -5 is equal to y minus 8 divided by 3 is equal to z minus 4 divided by 4. The question is find the equation of the sphere. Here the suppose this is the sphere, okay, whose center is known. The center, suppose C, the center is given 2, 3, -1, and this is the symmetrical line is given which is touches to the sphere. Suppose this is the line touches to the sphere. Okay, now here we have the center. If we find the radius from this point, means suppose this is the point of contact P, line and sphere, the point of contact P. If we find radius, then here we use center radius form and we can find the equation of sphere. Now the question is how we can find the radius of the sphere. Okay, now here the given data is we have the symmetrical line, we have the line which is touches to the sphere. It means the direction ratios of this line are -5, 3 and 4. See, we know the concept, one concept here. The concept is, suppose we have the vector A bar vector having component A1i, A2j, A3k, and suppose second vector is B bar whose component is B1, B2, B3, means B1i, B2j, B3k, and they are perpendicular to each other at particular point. Similarly, here the CP and this line is perpendicular. If these two vectors are perpendicular, okay, then the relation between them, their dot product A bar dot B bar is equal to 0. Okay, it means when we calculate this dot product with this component, that is A1 into B1 plus A2 into B2 plus A3 into B3 is equal to 0. Okay, and this component nothing but here the DRS of the line, DRS of CP, and if we calculate the DRS of the CP, okay, and just find out the product. So here we have the DRS of the given line, symmetrical line, -5, 3 and 4. Here we just find the DRS of the CP. So here we use the general point, say suppose K, and for some value of the K, these are the point of the P, and okay, and then this point, here the point P, and this we apply the formula. Here we can easily find out the DRS of CP. Okay, and then use the formula, we get the value of K, and then put K here, then we get the P point. Okay, once we got the P, then we apply the distance formula, we will get the radius. Okay, so let us go step by step. Let P be the point. Let capital P be the point of contact of the line with required sphere with given sphere. Okay, now we have the equation. So first we find the general point, that is x plus 1 divided by -5 is equal to y minus 8 divided by 3 z minus 4 divided by 4 is equal to k. So point of contact P is equal to, in bracket x, y, z is equal to. Now this we consider first and last term. Minus 5 is multiplied here and plus 1 it become minus 1. So we get first point x minus 5k minus 1. Now second, consider second and last. The 3 is multiplied and minus 8 it become plus 8. That is 3k plus 8. Okay. Now consider last two term. 4k z is equal to 4k and this 4 will be added. Okay. So here we get the general point for some value of the k, it is lies on the sphere. Okay. For some k, which is lies on sphere. Okay. If which is lies on the sphere, then we can find out the DRS. Okay. So DRS of CP. See, here we require the DRS of CP. We already have the DRS of the line, touches line, minus 5 and 3, 4. We just want here DRS of the CP. Now P is, this is the P point for some value of the K, which is lies on the sphere. So this is the P point. Now the CP, the DRS of the CP is minus this point minus means P point. P, the first point is minus 5k minus 1 minus this. That is DRS of CP R. Now this one minus this one. Yeah, you can take 2 minus this. Okay. Now I'm going to take P point. Suppose this is x2, y2, z2 and this is x1, y1, z1. x2 minus x1, y2 minus y1, z2 minus z1 in this. That is minus 5k minus 3. Now this minus this, that is 3k plus 8 and minus 3 plus 5. 4k plus 4 and minus plus, that is 4k plus 5. Okay. So these are the DRS of the CP. Now DRS of this tangent. DRS of tangent line. DRS of tangent line. That is minus 5, 3 and 4. Okay. Now CP, the CP is perpendicular to tangent line. We just discussed here the point. CP is perpendicular to tangent line. Okay. So we use a concept here. Suppose these are the A1, B1, A2. Sorry, A1, B1, C1. Sorry, I am considering here A1, A2, A3, and these are the B1, B2, B3. Then A1 into B1 means minus 5 into this point, DRS of the CP. Okay, this into this. Plus 3 into and 4 into. That is minus 5 into minus 5k minus 3 plus 3 into, now this is B1, now this is B2 into A2. That is 3k plus 5 plus 4, 4k plus 5 is equal to 0. Okay. Now simplify. Here minus 5 multiplied here. That is plus 25k plus 15. 3 is multiplied here, 9k plus 15. 4 is multiplied here, that is 16k. And here 20 is equal to 0. Now here 16 plus 9, 25 and this 25. That is 50 times k is equal to. Now here 15 plus 15, 30 and plus 20. That is plus 50 put in right hand side minus 50. So we get k is equal to minus 1. Okay. Now put k equal to -1 in the point of contact here. So we get the P point. Suppose this is the equation number 1. Put in 1. Put in 1. So we get P point X, Y, Z is equal to, so put k equal to -1, minus plus. Okay. That is plus 5 and -1. That is 4. Put k equal to -1, plus 8 minus 3. That is 5. Put k equal to -1, -4 plus 4, 0. So these are the point of the P, 4, 5, 0, 4, 5, 0, and these are the center. So here we find the using distance point formula, we find the R. So R is equal to, okay, 4 minus 2 bracket square, 5 minus 3 bracket square. Now 0 minus plus. Okay. So here we get, here 2 square is 4, 2 square is 4, 4 plus 4 is 8, and here 1, that is 9. So we get the square root of 9 is 3. R is 3. R is 3. Okay. We have already center. Now we calculate the radius. Now by using center radius form, equation of sphere is, x minus first point center, x minus 2 bracket square, y minus 3 bracket square, z minus, and here already minus plus, is equal to r square. R square means 3 square. Okay, so which is required equation of sphere. You can simplify this, a minus b bracket square. Okay, no problem. Which is required equation of sphere. Okay, thank you. Thanks for watching video.